Hello, Coach Holmes here, and today we're going to be talking about congruent triangles, or at least proving triangles that are congruent to each other. Now, there are at least 4 different postulates or theorems that we're going to use as far as being able to prove congruency between 2 triangles. The first one is side, 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 which we abbreviate as SSS. Now, what this means is if all 3 sides are congruent, then both triangles are congruent. So what does it look like? Well, simply we should have 2 triangles here. We have one side that is congruent, the second side is congruent, and the third side is congruent. Okay? So it literally means that all 3 sides are congruent to each other. If that's the case, then we have 2 congruent triangles. Next, we have side angle side postulate, which is abbreviated as SAS, which basically tells us if 2 sides and an angle in between are congruent, then both triangles are congruent. Okay? So again, it doesn't matter which side or which angle it is, just as long as it's side, angle, side in that particular order. Which basically means that if I'm going from side, angle, side, it's going to be congruent to the triangle side, angle, side. Alright? So it's really important that the angle is between the 2 sides here. That's very important. It can't just be, like for example, if I make this blue angle right here, it can't just be angle side side. It has to be side angle side. Next, we have angle side angle postulate, which is abbreviated as ASA, which means if 2 angles are 2 angles and a side in between are congruent, then both angles, let me write this out first. If 2 angles and a side in between are congruent, then both triangles are congruent. So what does that mean exactly? Well, again, if I have angle, side, angle, for both triangles, they're both going to be congruent. Now again, it doesn't matter if it was here, or here, or here, just as long as it goes angle, side, angle. That's very important. Okay? So again, it can't just be a side here and then angle, angle. It has to be a angle, side, angle in that particular order. Next, we have angle, angle, side postulate, which again abbreviates as AAS, which means if 2 angles and a side not in between are congruent then both triangles are congruent. Okay? Now, what does that mean? Now, it does mean it has to be in this particular order, which is basically showing that if I have the angle, angle, side, angle, angle, side. That is very important to keep in mind because I need to do angle, angle, side, angle, angle, side. Okay? So, I need to be sure that I do that. I need to be sure I'll be able to do that and be able to say that. It has to be angle, angle, side for both of these. Now, could I go this way? Absolutely. Because it's still angle, angle, side. Okay? Just as long as it's not in between, this will be angle, angle, side. As opposed to angle, side, angle. So if there's no side in between, but I have a side right here, it's angle, angle, side. So let's try a couple of examples real quick. So, samples to prove triangles are congruent. So, I want to be able to know which triangles are congruent. Well, if I have angle, side, and then I have side, angle, side, these are congruent because of side, angle, side. Now, this one's going to be a little bit tricky because I'm given two congruent angles, but I don't get congruent sides. But notice how this is the same line right here. Since they share the same common line, they're going to be congruent to each other. So I have angle, angle, side. So we can most definitely use the same side if they're actually connected to it that way. Next, I have side angles angle, 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 side. Now notice how these are two different tick marks. These two are not the same, which means that these are not congruent sides. Now some of you are saying, well, what about these two being congruent? There's no way of knowing that for sure. And I'm sure there probably is a theorem and a way to prove it, but we do not have it. We don't know that information yet. So we're going to put none, because none of the theorems that we use can actually help us to prove these triangles are congruent. Now I do have side angle, but I don't necessarily know if I have another side. But remember, they share a common side here. So, those sides are congruent. So I have side, angle, side. Now here's another one that's kind of tricky. Notice how I have the arrows here telling me that they're parallel. So I can most definitely use alternate interior or alternate exterior. Basically, I can use pair of angles from transversal parallel lines. So remember, I have these sides congruent. I know that for sure because they're reflective. They share the same line. And that's what it means. It's a reflective property because it's the same line. Now, because I know these two lines are parallel, these two angles are going to be congruent because of alternate interior angles. And because these two lines are parallel, again, alternate interior angles. So if I look at the side here, if I look to the side going up, these will be alternate interior. So looking at it, I have angle, side, angle, angle, side, angle. That helps me determine, I have angle, side, angle to help me determine that those two triangles are congruent. Next I have this triangle. I know that those two sides are going to be congruent because they're reflective of each other. Now I have angle, side, angle, 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 side. Now, they're not the same thing. Yeah, that's what I thought. Now, they're not the same thing. We don't use the same theorem, so this would be a none as well. None of the theorems we use works because we have to be able to use both of them simultaneously at the same time. We have to be able to use both and be able to say both. Otherwise, it could be congruent one way or the other, but because they don't share the same angle, angle, side, or angle, side, angle, it doesn't necessarily work. So what's very important is that we be able to use side, angle, side in that particular order for both triangles. That is the biggest key to it. It has to be able to work for both triangles. Thank you and have a good day.